not think we'll be able to test on Friday. I think the test will fall on Monday. All right. I just don't think we'll be fast enough to get there on Friday. I think Friday will be finish up review and then the test will be on Monday. All right. So in the opening, I only put 3 questions on here. Didn't mean to put radius. I don't have radius there. That is so not what I meant to have. I'm going to change that first one. It's not supposed to say radius. That's what it's supposed to say. Because I wanted to talk about the difference between ionization energy and electronegativity, because we had trouble with those two on the quiz Friday. All right. So if you did atomic radius, it's fine. Which one had the largest radius? I hear a little weak voice out there with an answer. What about the rest of y'all? Zaria, what'd you put? Okay. All right. What'd you put, Danielle? What'd you put, Gerardo?
Okay.
All right. So we got 3 Ks. Do we agree? All right. Now look at your periodic table and do ionization energy. Which one has the largest ionization energy? Since I changed the question. All right. So we're okay with NE. All right. Which one has the largest electronegativity? We're going to use it today. Does it have the same trend as atomic radius, the same as ionization energy? What is it the same as? It was the last trend we did.
Melting point.
No.
Atomic mass.
No. It is not the same as that, that's for sure. What's the trend for ionization energy?
Larger as it goes that way.
What's that way? Okay, that way. All right, so it increases, and then what happens is it goes down. Okay. So what's the trend for electronegativity?
It decreases as you go down.
Okay. So who's the biggest on the periodic table for ionization energy? Okay. Who's the biggest for electronegativity? Okay. That's the difference. Helium has the largest electronegativity when we talk about helium has the largest when we talk about ionization energy. Fluorine has the biggest when we talk about electronegativity. Okay? That's the difference between the two. All right? So you have to remember that electronegativity stops at the halogens, and electronegativity or ionization energy stops at the noble gases. So who has the largest ionization energy? Y'all said neon. So who has the largest electronegativity? Chlorine. Okay? Who's the most metallic? Yes. Okay? Because we know most metallic means what?
Reactive.
It means the most reactive.
And it has to be a metal.
And it has to be a metal since it says metallic. Okay? Are we good with that?
Yes.
Yes. Fabulous. We're on opening number what?
2.
Now, those of you who have not given me openings from last week, at this point, I've given y'all like 3 or 4 days to turn those in. The best you can do at this point is a 70 when you turn those in, because I have returned those to people. I'm tired of holding on to those things. All right, let's talk about bonding. Let me go back to see if I have it here. No, that was just for my notes. Try this one. That's where I want to be right there. All right, so we talked about what is a bond. We talked about ionic bonds, covalent bonds, metallic bonds, and we had not talked about how to determine the type of bond. Now, when you do this, I want you to use your periodic table, and I want you to leave a little space between each of them. All right. Do not make it really super tiny because we're going to come back and do it another way. I will tell you that there are some errors in this the way we're doing it. Okay?
Wait.
As in some of those y'all are going to predict wrong. 5 o'clock.
Oh, ionic or covalent?
Oh, I left out the word bond. What are the 3 types of bonds that we talked about?
Ionic, covalent, and metallic.
Yes. So tell me which types they are. Ionic, covalent, and metallic. All right, so we already need a review. So how do we tell something's ionic?
Metal and non-metal.
Good. How do we tell if it's covalent?
Non-metal.
All non-metals. And how do we tell if it's metallic?
All metal.
All metal.
Or even one metal.
Even one metal.
Spaghetti.
I got a content. I know you got a
No. Now, I would hope after being in here for right at 10 weeks, we would know where some of those elements are without having to look. But if you don't, then look them up.
Salt.
Yes, NaCl is salt.
I like that one. False. Okay, expression. I think you want to learn that this week. Okay. ECL. Phosphorus. Wait, I don't see those.
Say give a lot of space.
Okay, the second one's ionic too.
This is not.
Yes, it is. Phosphorus and chlorine.
Oh.
She got.
No, every other day.
Are you okay?
But you're not mad with you. She's not mad because she gave us a paper and she stapled it and she did that.
All right, you got it?
No!
Come on, hurry up.
I'm coming.
She said the person who told her got extra credit.
Yeah.
Is
Is what's supposed to be capitalized?
No, bro, you. How you doing?
Yeah, capitalized, capital S. I just do the chlorine.
You already know.
Like leave like lines in between.
I may be one, just because we're gonna come back and do something else with it.
Oh,
Just
alright.
one.
Just one should be plenty.
I'll put it over here.
That's fine, you can put it up, it's all right.
I think,
I just know some people, squish everything up real bad.
Which one do you want to use?
CL2.
So sad.
Metallic.
Now, this chart that I'm giving you while you're working, do not write anything on it other than your name, because you get to use it on the quiz.
Wait,
This week. If you write stuff on it, you don't get to use it on the quiz.
What are today's notes called?
Bonding.
Yes.
Types of bonds.
Put on front.
What?
What we're doing?
Yeah, it's still a continuation of Thursday, which were types of bonds. I'm just picking up where we left off.
Can I write my name on it?
That's what I just said. No kidding. All right, we done? No. Is that a just kidding like in yes, you're done?
Yes. I don't know, but I'm not the only one working, so I don't know if everyone is done.
Who am I still waiting on?
Me.
Yeah, the last time I walked by you, you hadn't even written the questions down.
I'll show you how much you got.
Really?
Spaghetti.
Next time I have to borrow one.
What is this called?
Bonding. Types of bonds.
Ouch.
All right, so if we look at number one, what can you tell me about NaCl?
Ionic.
Okay, everybody should have come up with this was a metal and a non-metal, so it's ionic. All right, what can you tell me about P and Cl?
Covalent.
All right, it's a non-metal and a non-metal, so it's covalent. C, A, and I would be
Ionic.
ionic. It's a metal and a non-metal. What about H and F?
Oh.
A non-metal and a non-metal, it's covalent. Okay? H is way over there on the left, and even though it's on the left, it's a non-metal. So you have a non-metal and non-metal. What about C and H?
Covalent.
It's covalent. They're both non-metals. Now, Cl and Cl is a chlorine bonded to a chlorine. So it's two Cls. Okay? So it's what?
Covalent.
It's covalent. Okay? And a lot of times people look at it and they're like, is that a trick question? But we don't write ClCl. We write it as Cl2. Okay? But it is ClCl. All right? And then iron is what? What's iron? It's a metal. So it's a metallic bond. Okay, everybody good with us? Anybody confused by how we came up with any of those answers? Yes or no? No? All right. Now, two of those answers are actually wrong. Now, if the state gave you just a periodic table, you would have no way of knowing which ones are wrong. But there's a more definitive way to find the types of bonds, and that's why I gave you a periodic table, okay, that has special numbers on it. All right? So a more definite way to find bond type is to use electronegativity. All right? Remember, electronegativity tells us who controls the electrons in a bond. So, if Victor and I are tugging on the electrons with the tug of war rope, one of us might be stronger than the other. Okay? If I'm stronger, I have more pull on the electrons. If Victor is stronger, he has more pull on the electrons. If we're roughly of equal strength, neither of us has more pull on the electrons. Electronegativity tells us who has greater pull on the electrons. Okay? So, we can use electronegativity to figure this out. Do not write this on the chart. So, the electronegativity scale, which is right there, is what we're going to use to figure out bond type. Now, who is not on that scale at all? What type of bond is not on the scale at all? Metallic. You cannot use that scale to find metallic. You have to recognize a metallic bond outright. Okay? You have to look at the bonds and go, oh, that's a metallic bond. You cannot use electronegativity to find a metallic bond. Did everybody hear me say that? You cannot use electronegativity to find metallic bond type. Did everybody hear that? Okay, we're going to practice it. But hear me, you cannot use electronegativity to find a metallic bond type. Now, you have to memorize this scale. There's only 3 numbers. 0, I sort of figure everybody can keep track of. We'll talk about what it means to be polar and nonpolar in just a second. From 0 to 0.3 means that you're nonpolar covalent. From 0.3 to 1.7, you're polar covalent. And from 1.7 to 4.0, you are an ionic bond. Okay, do not write it on that chart that I just handed you. Now, how are we going to figure out what type of bond we are? Now, to determine the bond type, all we do is subtract. We subtract the electronegativities that I just handed you on that chart. That's all we do. We subtract the electronegativity of each atom. It will always be the positive difference. Okay, whatever the positive difference is. So it doesn't matter which number you subtract first. We always keep the positive difference. Now, did I say anything in there about subscripts?
No.
No. So the subscripts don't matter. Okay? Subscripts are irrelevant. We don't care about them. So, if we have these two compounds, one of them has no subscripts, one of them has subscripts. All we do is subtract the electronegativities and get the positive difference. So NaF. What is NaF's difference? Well, using the special table I just handed you, what is Na's electronegativity? 0.9. What is F's? So 0.9 minus 4.0. Remember, it's the positive difference. So it's like being in absolute values, and you get what? 3.1. You can have a calculator in a minute if you need it. Okay, so where would 3.1 sit on this number line? It would sit up here. So it would be what kind of bond? It would be an ionic bond. All right. For the second one that I gave you, CO2. Did I say anything about using any subscripts? We only use C and O. So we look up C. What's C's number? 2.5 minus what's O's number? 3.5. What's 2.5 minus 3.5? 1.0. All right, so from there, what kind of bond would it be? Where does it sit on the number line up here? If I can. 1.0, polar covalent. And I'm going to abbreviate PC just because I'm lazy and I don't have a lot of space. So polar covalent. Questions about how to use the number line or how to use the numbers on the chart. It really is that simple. Okay? You with me? Janai, you with me? You're just sort of staring across the room there like, please God, get me out of here today. Just think, if we were in the county schools, y'all would all be home asleep. All right, so what does it mean to be polar covalent? Precious is already home asleep. All right, so polar covalent means it's a bond where the electrons are not shared equally. So if we were playing tug of war, Victor might be dragging me across the room. All right, it's a bond where the electrons are not shared equally. In the tug of war game, one team is winning. They're pulling the other team across the line. Okay, one atom is stronger than the other. The electrons are not shared equally. So, in one such as HCl, if we have electrons being shared, hydrogen has 1 electron, chlorine has 7 electrons. These electrons are being pulled over by chlorine. We know this because hydrogen wants to do what with its electrons? Wants to get rid of them. Okay? Hydrogen wants to lose, and chlorine wants to do what? Wants to gain. Okay? Now, that's what it means to be polar covalent. They still share, but they're not shared equally. One of them is stronger than the other. Sort of like magnets. Now, non-polar covalent means the electrons are shared equally. Okay? No one is pulling harder than the other. Sort of like you've been cloned. Imagine two Michaelas. It's a little scary. But let's assume that there's two Michaelas. Okay? And she's playing tug of war with herself. Okay? So if we have Michaela playing tug of war with Michaela, all right? Would either Michaela be stronger than the other Michaela? If we were able to clone her and she was exactly the same? No. All right? So if she's exactly the same, neither Michaela is stronger than the other, so she can't pull on one electron harder than the other electron, right? Theoretically, that would be the case. So, if you had a bond between two chlorines, two electrons being shared, how many outer shell electrons does this chlorine have? That's 7. And this one has how many? 7. So, they're pulling. Are either of them pulling any harder than the other?
No.
No, they're pulling with the same strength. So they're shared equally. Okay? Same strength. Yeah. All right, are we caught up? Yes, no? All right, so I want you to take that same list that I told you to leave space for. The only thing is, let me see if I can make it fit. All right. There, now it fits. All right, so using the electronegativity number line. All right, this time, go through and find their bond type and see if any of them are different. You should find at least one, maybe two, that are not what you predicted the first time. I don't care if you rewrite them where you're at in the notes or whether you go back and do them in the same place. My intent was for you to go back and do them in the same place you did them so you don't have to rewrite them.
With the line thing?
Yeah, with the electronegativity line.
All of them.
Just so you had less to write.
All of them?
Yeah, all of them. That way you can find out if any of them are wrong.
Well, you already told me.
I already told you, you should find some wrong. Well, I didn't know about Allie's target here.
Mm-hmm.
Can I get a calculator?
Yes, any of you who need a calculator can have a calculator. I know y'all can't subtract decimals.
I can't.
That's why I said go get a calculator.
How about that people's watch is not working?
It's okay. I'm used to it.
Anybody else want a calculator?
Yes.
Happy birthday.
Whose birthday is it?
Thank you, ma'am.
I don't know. I just said happy birthday.
I know, I didn't look at my attendance, so whose is it?
No,
Yours?
who wants to say their birthday today?
I was thinking there was somebody in one of my classes that was,
We gonna be Trevor's birthday.
All right, Trevor, you want to be your birthday? Happy birthday, Trevor. Let's go to a party.
you remember what day it was on?
You want his birthday?
Alec.
Oh, no.
Of course not. Okay. See if we can find the target.
What in the world?
What in the world, what?
I don't understand how these can change from like covalent to ionic using a scale.
Alright. Was the Thursday before you were out on Friday? What day were you out on Friday?
I don't know.
Just when I was, I guess you marked me tardy when wasn't that absent on that Thursday too?
Yeah, you were. That's what I did. You were absent on Thursday and Friday. Yeah, you should be absent, not tardy. See what date it is, because I cannot read this stupid thing. The 26th. You should be absent September 26th.
Yes.
So if you only have like one element like double, is it just like the number? Or is it 0?
Hang on. All right, what did you say? I have fixed her, or tried to fix her tardy to an absence now. All right, what'd you say, Michaela?
I said, if you have two of the same element, would you just use the number or would you?
You would have to subtract it because that would be the same things like up there, CL, CL. We just don't write CL, CL. So you would subtract, you get 0, yes.
Oh, wait, so what is that?
So when you write CL2, okay, where to put the pen? There it is. So this is like having CL, CL. Okay, we write it as CL2, but it's the same thing as having CL, CL. Okay?
Wait, so 0 doesn't have a name?
It's.
Yeah, where is it on the number line if it's at 0? I knew you did. Never doubted it for a second.
Wait,
You look tired.
So we never pay attention to this.
Nope, we don't care about the subscripts. The only time we care about the subscripts is like at CL2, so we recognize it CLCL. Okay, because we write that one different than we write all the rest of it.
So would it be like that with a metallic?
No, no, you have to recognize that if it's a metallic element, it's just a number. Okay? All right, so we have time to try them all?
Yeah.
Okay, so for NSPL, all right, what did we get? Let me change my color here. All right, what do we get for NA? Because I need the numbers. We're going to do something with them in a second.
2.1.
2.1. That was what you got when you subtracted?
Yeah.
Okay, so what type of bond was it? Okay, and PCl5, what'd you get?
0.9.
And what kind of bond was it? Okay, and CaI2, what is the bond difference?
1.5.
1.5, so that would be what? Polar covalent. Okay, and y'all had that predicted at what last time? You had that predicted as ionic. So on the exam, if all they give you is the periodic table, you'll look at the periodic table and go, oh, it's a metal, non-metal, and you'll say it's ionic. But if they give you electronegativities in the question, they're going to expect you to subtract and figure out that's polar covalent. Okay? You won't get this whole chart. They will give you a small table of electronegativities, and they'll expect you to know what to do with the electronegativities. Does that make sense?
So they're not gonna give us.
They're not going to give you the whole chart. There'll just be a small table of electronegativities in the question. Okay? So, HF, what'd you get? 1.9 will be what? So, same thing. You had that one labeled as covalent, and it's actually an ionic bond. All right, CH4 will be what? 1.1, and that'll be polar covalent. And this is the one that trips people up a lot of time because they see Cl2, they look on the chart and they go, oh, it's what, 3.0? And they want to label that as ionic, and it's not. It's the same thing as having ClCl, so it would be 3.0 minus 3.0, which is 0, and you get what? Non-polar covalent. All right, now, anytime you have something that's just a metal, one metal by itself, you do not use the chart. You don't look up an electronegativity. No chart. It's just a metal, so what kind of bond does it have? It's metallic.
I'm confused about how, like, even though it'll be a metal and non-metal, it'll be like a valent or something. Like, just because of the numbers.
It's just the way the electrons tend to do what they do.
I don't know.
It's just what happens. All right, now, the last thing we're going to do with bond type is rank these in order of increasing ionic character. Okay? So on your scale from 4 to 0, where is the most ionic character? Based on the number, where's the most ionic character? 4. Okay? So the most ionic character is at 4. So you have to go this way. So you're going to start at 0 and go to 4.0. Okay? Because you said the most ionic character is at 4, you're going to start at 0 and go towards 4.0. Does that make sense? Yes or no?
Yeah.
Okay. So that's why I said we needed the numbers, and I wanted you to tell them to because we're going to use those to put them in order. Now, who does not go on the list at all? Fe doesn't go on the list because it has no number. Okay? So you're going to leave metals out. All right, so who had the least ionic character? Who?
CO2.
Cl2 had the least. Okay, then who?
Oh, the next out of our list.
Mm-hmm.
PCL.
PCl. Next.
CH4.
Next.
Hold on. CI. Oh, no.
All right, Cl2. This one, I think y'all missed one. Let me see. Y'all missed one? Now we got PCl3, Cl2, PCl3, CH4, CAI5, CAI2. All right, what else?
HF
HF.
and NaCl.
Okay.
Is it wrong?
What's wrong with it?
I don't know. You just looking like something wrong.
No, I'm not.
Okay.
I mean, unless you put something out of order based on number, I'm not.
Okay.
It looks right.
Why did you put PCL3?
Oh, well.
Because I listen to Michaela.
I'm sorry.
I'm sorry.
Oh, I didn't put.
Oh, 3, it's a 5.
I didn't even do it. So it's not Nicola's fault.
It's close enough. It was close enough. All right. Now, What if I said tomorrow on the quiz,
In order.
all right, how would that change the question?
Then you would only have the covalent. Wait, I don't
I
know.
don't
Yes,
remember the other question.
yes.
You would include everything,
Oh,
but how does it change the scale?
maybe go with opposite.
Okay, so we've got to go towards what number?
Oh, 0.
All right, so your scale is still 4 to 0, right? Where's the most covalent character on the scale now? 0. Okay, so your most covalent character is here.
Oh.
So now you're going to put your list and go from where to where.
0 to 4. What?
Think about how we just did it. We started at 0 and went towards 4 because 4 was the most ionic, right?
4 to 0.
That's right. So now we would start at 4 and go towards 0. Okay, when you're doing ionic, you go towards the 4. When you're doing most covalent, you go towards the 0. Depends on how they ask the question. Does that make sense?
Yep.
Yes or no?
Yes.
You're going to be asked to do this tomorrow. I'm just telling you now. So can everybody do this?
Mhm.
Can you find bond type and can you put them in order? Uh-huh. Okay. Yes, no. Anybody not? You can't? All right, so does everybody have this? Because I'm going to leave that question. All right, and we're going to have, let's see. All right, rank those in order of covalent character. And then we'll talk covalent bonding the rest of the day.
Wait,
What's happening?
No, this is it. Rank in order of covalent character.
That's all.
Yes.
You know how they have like melatonin to help you sleep? Do they have something to make you wake up?
Yeah, like no dose or something like that. It's a form of speed. It's a stimulant.
So isn't it illegal?
Speed is no dose. Is it?
what do I get?
How do you use that? Oh,
They don't sell speed. You just want a stimulant.
They sell
But like, do they sell stimulants like in like a CVS or something?
Yeah.
Okay. CVS.
I mean, an older version is called no dose. I don't know what they sell now.
It is, but when you're doing that, it's a little before. It's a little bit.
I mean, most people, drink coffee or something now, but.
No, I'm gonna just crap.
what it goes to?
What are you talking about?
But yes, they sell stuff like that. You just have to get it.
Can you get it from like over the counter or you
Yes.
have to have it?
You can get it over the counter.
You can get melatonin.
Crazy about those stimulants.
I mean,
You're gonna be addicted.
too.
You're gonna be addicted to these vitamins.
Oh, I
Dang, I
Babe, I-
I need that.
I got that one's good.
It's good.
Yeah. Process.
I felt like that.
It was a very ridiculous.
All right, we got it?
Wait, no. So for SO, you would literally do S and O.
Yes.
So what?
S and O.
Mm-hmm. That's a fact.
Ooh, I'm talking salty. You like saltines as well?
Yeah, if I'm sick or having chicken noodle soup.
Could you eat them by themselves, like with no drink?
Me?
Man, you can eat some things by
Peanut
themselves.
butter and saltine.
Might as well
Stop
be some
talking
sandwiches.
Peanut butter.
Peanut butter and salty. Your mouth is dry. That's it.
It'd be like that sometimes.
Breathe.
A 25.
Let's see it.
I don't hear.
It's supposed to be C5.
Wait,
Let's see S or C5.
Where at? CSCL.
Some of the demon of the
What's M summary? Oh.
Where is it? Okay. Oh, I found it.
this long.
Yep,
Look at that.
I can't fix that for you.
Okay. Where's TE? Oh, never mind.
Oh, no.
Noises in it.
No. I made it. I
You were something.
feel bad.
You just said she was.
Yeah, she did it earlier, but feeling. Okay. Numbers everywhere.
I went to
Oh, you
last night, and like there was these little like when I go to I have like jokes about everybody or like I'll be terrified out of time. So I said something. They had the little kids one, and he said something, and I was
You
begging
texted
everybody
her,
back.
so you gonna talk about her dad.
And try to argue with me. I was like, what?
I cannot argue with kids. That is. I was not talking about you guys. I think
I did something, but they couldn't not control it all.
Well, we have a soft
I don't have the 6 homebody. Alright, so can we look at what y'all came up with? Alright, so SO2, what did you get? You got 1? 0.0? Alright, what'd you get for TeCl2? 0.9. And Br?
0.
And Mn?
Metallic.
Okay, so we'll just put nothing there. Alright, CSCl. Alright, so if I say covalent character, we're going from where?
4.0 to 0.
Alright, so we're going from 4.0 towards the 0. So, what number or what compound should I have first? CSCl, and then who? SO2, and then the TeCl2, and then last, Br2. Do we have it?
Yes.
Okay. All right, let's talk covalent. So,
Wait.
what?
I want to get my coffee. Okay.
Okay. So, for the rest of today, tomorrow, and a good part of Wednesday, we are only going to talk covalent bonding. Okay? So, every time I use the word covalent bonding, I want you to think shared electrons. Okay? Because we're going to learn after we do some vocabulary. We're going to talk Lewis structures today and tomorrow, and then geometries and how to tell if they're polar or non-polar. In order to do that, you have to remember that we're talking shared electrons. Because when we switch to ionic bonding and metallic bonding, the electrons are not shared. We cannot draw Lewis structures when we talk metallic and ionic bonding because the electrons are not shared. Lewis structures are unique to covalent bonding. The vocabulary I'm getting ready to talk about is unique to covalent bonding. Now, the first thing we're going to talk about is the definition for a molecule and a diatomic molecule. Now, a molecule is 2 or more atoms covalently bonded. Now, When I say covalently bonded, what do I mean? I mean the electrons are shared. So, if I ask you on a quiz or a test, which of the following are molecules, I expect you to be able to tell me based on what we've done Thursday and today. Now, out of those 8 compounds that I put up there, some of them are molecules, some of them are not. You should be able to tell me which are molecules.
I thought those were elements.
Elements cannot be bonded to anybody else.
Oh, I meant, but, okay. They are elements.
So, how do we decide who is a molecule if I ask tomorrow on the quiz?
The chart,
What about the chart?
the line, use it.
Okay,
If it's covalent or not.
okay, that's not a bad answer. That's pretty good. All right, to be a molecule, you have to be covalent. So the first thing you might want to figure out is if you're covalent. Because if you're not covalent, you're automatically not a molecule. So you can use the chart or you can use the periodic table. I don't care which. All right? So what are we doing?
What number?
Wait, you wanted us to put which are covalent molecules, or you just wrote?
In order to be molecules, you have to be covalent. Okay? That's what Michaela's telling you. So she said she's telling you to do this. She's telling you to use that to subtract and figure out if you fall in that 1.7 to 0. Because if you do, then you're a molecule.
That's your
So, does NaCl fall in that 1.7 to 0? Is it ionic or covalent?
ionic.
Okay?
What?
I'm asking y'all. I know the answer.
Yes, ionic.
It's ionic.
I
Okay?
don't know.
What about KBr?
Yeah, I think it's ionic.
What about CO2? HCl?
Covalent.
What about SO2?
Covalent.
PCl3?
Covalent.
MgCl2?
Ionic.
And LiF?
Ionic.
All right. I know Michaela has got it. The other we have one absent. 18 people? I got no idea.
I'll shut up.
Okay? How did she figure out if they were ionic or covalent?
Looked at the periodic table.
And what did she find on the periodic table?
And then metals and non-metals.
That's one way to do it. You can simply look if they're metals or non-metals. How else can we do it that we've learned today? What about the chart? Tyra? Subtract the electronegativities and decide for what? Sure. Either answer. Okay? Could you do that tomorrow on the quiz? If I asked you to do that. Along.
Yes.
You could.
Yes.
Okay. Huh? With a line thingy, you could do that. Okay, so how do we figure out if they're molecules or not, Sam? Okay, so now that we know they're ionic or covalent, how are we going to know if they're molecules or not? Huh? Nope, we already know if they're ionic or covalent, so we don't have to minus anybody. Daniela, how do we know if they're molecules or not? If they're covalent, they're automatically a molecule. So which ones are molecules? Those are your molecules. Okay? Those are your molecules. Are you with me on that? If you labeled it as covalent, it's a molecule. Yes, ma'am.
So wouldn't you have to use the subtractory because you said that just looking at this thing wasn't like a definite answer?
Usually, it's not always, but a lot of times it can be. Okay, I didn't give you anything that's going to fall on the line there. All right, so which of the following? Let me give you this definition, and I'm going to come back to it. A diatomic molecule. What's a diatomic molecule? Think math class. What does it mean to be diatomic? Two what?
Atoms.
2 atoms. Okay, so this one is 2 atoms covalently bonded. Okay? 2 atoms only. All right, so we're going to go back to the same 8 examples. All right, 2 atoms covalently bonded. And we're going to go back to the same 8 examples. Everybody have it? All right, so if I go back to the same 8 examples, go back. All right. Now, which are diatomic molecules? Xavier, what do you think are diatomic molecules? You hush.
Some like two like compound or something like that. You gotta do something about it.
Okay, it's got to have 2 what? But the definitions that you just wrote down.
Oh shoot, I got a covalent bond.
Okay, it's got to be covalent. And what else?
Bonded.
It's got to have 2 what?
atoms, yeah.
2 atoms. Okay? So, who can we automatically get rid of? Out of those 8, who can we automatically get rid of? So, Randy, help him out. Who do we can get rid of? Okay, you. Why would we get rid of them?
The ionic bonds.
Thank you, Victor.
Oh, shoot.
I said out of the 8. So these should go because they're ionic. Okay? Those 4 should go because they're ionic. Is everybody okay with that? Now, out of the 4 that remain, who should go?
CO2, SO2, and ECO2,
Why?
because they have subscript that make them.
Correct. How many atoms do we have here? 1 plus 2 is 3 atoms. It's got to go. 1 plus 2 is, it's got to go. 1 plus 3 is, it's got to go. The only one that's diatomic is 1 plus 1 is HCl is diatomic. It's the only one up there that's diatomic. It's covalent, and it has how many atoms? 2. Now, it doesn't have to be one of the 7 diatomics to be covalent. Does that make sense? Okay, I could have given you one of the 7 diatomics, but you would have all gotten that immediately, right? So I wanted to have something that was a little different. Everybody with me on that? It has to be covalent, and it has to have 2 atoms. Only 2 atoms. Is everybody okay on how we counted? All right, so All right. Figure out which ones are molecules and which ones are diatomic molecules.
Can I just use the
Sure. I don't think I gave you anything that's so close that you would have trouble figuring it out. I don't think I did. All right, so what do we come up with? What are my covalent compounds? Give me one princess. One covalent compound. Say it loud enough I can hear you. Remember, I'm old. I'm getting deaf. I can't hear you. I said covalent. Any one covalent compound. You really can't tell me a covalent compound? Who? Sure. PR is one. Okay. So you got your periodic table handy? Okay. Where's SI at on the periodic table? It's on the left or the right of the staircase? Okay. Where's BR at? They're both on the right. Are they metals or nonmetals? They're nonmetals. So if you have two nonmetals, is it ionic or covalent? Covalent. So SiBr is what? Covalent. See, you found one. I meant Cl. There you go. All right, give me one.
Are you just circling them because they're
Covalent at the moment. Yeah, we're just doing covalent at the moment. All right, who else I talked to today? Raylene, give me something that's covalent. HBr. Give me something that's covalent. Jocelyn, I haven't talked to you. SO3. Give me something that's covalent. Zaya. Give me something else that's covalent. Zaria. Who?
CO.
CO. I like that so much better. All right. So, out of those choices, because the rest of them should be ionic. All right. This is a metal and non-metal, metal, non-metal, metal, non-metal. Okay. They're all starting with a metal. As soon as they start with a metal, for the most part, they should be ionic. Okay. Everybody with me on that? So, out of the remaining choices, to be diatomic, they can only have how many elements? 2. And of those 2 elements, when you add them together, they can only have how many atoms? 2. Okay? So when you add their subscripts, they can only have 2 atoms. 1 plus 1 is 2, or there could just be a 2-1. Okay? So, Serenity, give me something up there that's diatomic. All right? This one is also diatomic. All right, give me something that's diatomic, Precious. You're awake, so let me get you while you're awake. CO is diatomic. Okay? Give me something that's diatomic, Zaya. HBr. Give me one last thing that's diatomic that's up here, Sam. IF. All right, are we good on that vocabulary? Yes? Fabulous. All right. The 3 types of bonds we're going to learn to draw. All right, so we're going to learn to draw Lewis structures tomorrow. All right, there's 3 types of covalent bonds we're going to learn to draw. You may have learned these types of covalent bonds in another science class before. I would almost be willing to bet that you've talked about them before. Okay? They are called single, double, and triple bonds. We will start with the easiest tomorrow, which will be the single bonds. And then we will work towards double and triple bonds. Now, in a single bond, you have a shared electron pair. Now, an electron pair means that there are 2 electrons. In a double bond, you have 2 shared electron pairs, which means you have 4 electrons. And in a triple bond, you have 3 shared electron pairs, which means there are 6 electrons. When we draw these tomorrow in Lewis structures, it might look like this, this, and this. All right, because we will draw lines to represent the bonds tomorrow. Lewis structures are not that difficult to draw once you get the hang of it. It's sort of branching out from dot diagrams. And then on Wednesday, we'll learn to tell their geometries. Now, we need to talk about bond energy and bond length. And then we can actually start Lewis structures today. Need a different color. Now, if any of those you get out or dry or don't write well, throw them in the trash. Don't put them back in the bucket. All right, is everybody caught up? All right. So we're going to start with bond energy. Okay, bond energy is the energy needed to break a bond. Okay, you can sort of think of this as bond strength. Okay, it tells us who's stronger and who's weaker. So, out of the 3 bonds, who would be the strongest and who would be the weakest?
Let's have.
I'm talking about single, double, and triple.
Triple bond.
Which one?
Triple bond.
Triple is the what?
Strong.
Yes. A triple bond is the strongest. And that would make who the weakest?
Single bond.
Mm-hmm.
So this is only for covalent.
Yep. A while ago, I told you we're only talking covalent the next 3 days. I will tell you when we switch. But right now, we're only talking about covalent bonds. When we start talking about molecules and diatomic, we're only talking covalent. Lewis structures, only covalent. Geometry, polarity, only covalent. Okay, I won't talk about ionic until probably late Wednesday. All right, are we good?
Yeah.
All right, So, the length of a bond, okay? Bond length. Is the average distance between two bonded atoms. Now remember, atoms are always in motion, okay? They're in constant motion. They never stop moving, so they vibrate constantly, okay? So if atoms are constantly moving, can we measure the distance between my hands if they're constantly moving like this? No, we can measure it at various intervals and then find the average, okay? So atoms have three types of motion. You'll get tired of three of everything in this unit. Number one is called vibrational motion, which is what I just showed you. Number two is translational. So when you guys get up to leave to go to second period, y'all are going to translate, okay? It's the only kind of motion I have. So when you go from point A to point B, you translate. And number three is rotational. Maybe some of you have the ability to flip. It was never a skill I had. I was always afraid I'd land on my head, so I could never acquire that skill. Could you do it?
Yeah, I always live on my
Oh. I was always afraid I was going to land on my head, so no, couldn't do it. All right, so vibrational, translation, and rotational. All right, so because atoms have these three types of motion, we can measure the distance between the atoms, but they're always moving, so we have to measure them at various distances and then average. So given that, which bond has the most distance and is the longest? Who will be the longest? Single. Okay, the longest is the single bond. All right, and that's one of the reasons it's the weakest. All right, the longest bond is the weakest. Who will be the shortest bond? The shortest is the triple bond. Okay, the shortest bond is the strongest bond. So that means the mid-length and the mid-strength is the double bond. It's always in the middle. All right, questions about that?
No.
Everybody good with that one?
Yeah.
All right, because we're going to start at the beginning of Lewis structures.
Anybody know what's done with the
It's the best different segments.
Mm-hmm. All right, so for those of you who like to label sections and that, we're going to switch to a different set and title. Okay, and we will continue this tomorrow. So you will not need a new set or title tomorrow. All right, everybody have what they need? All right, this ends the quiz for tomorrow. Okay, nothing I'm going to do now would possibly be on the quiz. Anything through there is fair game. Nothing for the rest of the day will be on the quiz. All right, we're going to draw Lewis structures tomorrow. But we can start it today so that tomorrow's not quite so hectic. Didn't I just say that? Yes, I did. Bond types, being able to tell the types of bond using the periodic table, electronegativities, ranking them in order, molecules, diatomic molecules, any of that stuff. Yes, we have a quiz tomorrow. All right. Now, Lewis structures are pictures to illustrate the bonds in a molecule. Now, if I said molecule again, what kind of bonds are we illustrating?
Covalent.
We're illustrating covalent. Okay, because I said molecule, we're illustrating covalent. Lewis structures only illustrate covalent. Now, drawing Lewis structures, I think is pretty easy. Because you guys already know how to draw dot diagrams. Dot diagrams are really called Lewis dot diagrams. I just leave off Lewis. Yes, ma'am.
Who's this?
He was a scientist who created it.
Oh, we don't like that.
Nope, not unless you want to. It's not part of our curriculum, so I just leave him out. It's named after him, but. All right, so there's several steps to do this. Number one, let me just start it on new board. That way I have more space. All right, so the steps. Number one, count the valence electrons. What do we say valence electrons were again?
Outer shell.
That's right, outer shell. All right, number two, determine the central atom. All right, determine the central atom. Now, a couple different ways you can do this. It's the atom you only have one of. For example, SO2. S would be the central atom because you only have one S. Okay, O would not be the central atom because there's two of those. S you only have one of. Does that make sense? Yes? Okay. Now,
Those are the only two steps?
no, there's 4 steps. All right. Now, sometimes it's a little trickier. It's the atom farthest left on the periodic table, except hydrogen. Hydrogen can never be the central atom. For example, suppose you had NOF. Your central atom here, when they have no subscripts and you have one of everything, who would be farther left on the table? So you'd have to look up NO and F. N, so N will be the central atom. And it's not always written first, which is why it could just as easily have been written in some places O and F, and it would still be N. It doesn't matter the order of the elements. So you can't say, oh, it's written first. It's got to be the first element. It doesn't have to be. Okay? So, number 3. The remaining elements go around, key here is go around the central atom. They don't make a line. Chains are not part of our curriculum, so they're never going to be in a line. Those of you who take organic one day will deal with chains. And number 4, the total electrons from step 1 are placed around the elements until each has 8 electrons. If they don't all have 8, rearrange until they do. that rearrange until they do is where the double and triple bonds come in tomorrow. Okay?
I know. That was kind of.
Yeah.
What are you yelling about over there?
I don't even know. What? Here we go.
Oh, it was.
All right, are we caught up? Yes, no, maybe?
Yeah.
All right, let's talk about how to do one. We're going to do an easy one. We're going to do CCl4. It's as easy as they get.
Is this an example for that four?
What's the example for all of them? You're going to do the whole thing. I can't give you an example for 4. All right, so step 1. Add up the valence electrons. All right? How many elements do we have? Okay, so we're going to add this up just like we did mass all those weeks ago. C and Cl. How many C's do I have?
Wait.
How many Cl's do I have?
Oh,
Okay. So we need to find their valence electrons. How many valence electrons does carbon have?
4.
How many does chlorine have?
7.
Okay. Now, for those of you who are too shy to ask me and don't know, carbon is here, chlorine is here. Okay? So carbon has 4 and chlorine has 7. If you can't find those, you are toast in this section. Okay? If you can't do that, please come see me today. All right, so carbon had 4, chlorine had 7. So we're going to multiply and get 4, 28, add, we have a grand total of 32 electrons. Okay? So that's how many have to be in our structure when we get down to step 4. So, number 2, determine the central atom. So, either look to see who's farther left or who we only have one of. We only have one C. So our central atom will be carbon. Step 3, all the remaining atoms go around the C. Well, we have how many chlorines?
28.
We have, no, I said how many chlorines?
Oh, 4.
We have 4 chlorines. So we're going to draw 4 chlorines around the carbon. Now, if we only had 2, we draw, whoops, we would draw 2. But our structure says we have how many chlorines?
4.
So I'm drawing 4. If it said 5, I'd draw 5. If it said 3, I'd draw 3. But
Wait, where did you draw it?
Right, I didn't see it, but while you were active.
Right, you moved. Oh my gosh.
the board and I are not getting along today. Like that.
Alright.
All right. So are we okay with the formula has 4, so I drew 4. Okay. You draw however many the formula says you have. Okay. If it said NOF and I said N was in the middle, how many O's would I draw? So if we had this formula that was right here, okay, and we said N was in the middle, it'd be how many O's? I'd draw 1 O on one side, and how many F's? I'd draw 1 F on the other. Okay?
Wait, so if it's 3.
If it's 3, I'm going to do what?
Like, so if it was C, Cl, and then another element, and it was like one of the other one.
So if it was C, Cl, and what?
Another element.
So C is in the middle.
You would do the 4 Cls, and then
Well, how many, did I have a subscript here?
if it was the 4 Cls.
And then it was just the VR by itself.
And then put a BR in.
You wouldn't have.
But Elijah,
You don't have to draw it to specific.
no. Yep. All right. So we have 4 CLs. Are we okay with steps 1 through 3?
Yes.
Okay. Step 4 is usually where people have the hardest time. But again, we're starting easy. All right. I have to draw in 32 dots. Okay. Don't draw the dots yet. Hold on, and I'll let you come back and draw the dots, and we'll label the vocabulary tomorrow, most likely. All right. 2, 4, 6, 8. There's 8 of my 32. All on the carbon, right? Where am I going to draw the remaining electrons? Around who? Okay, so there's 8, 10, 12, 14. That one's full. 16, 18, 20, 22, 24, 26, 28, 30, 32. Now, you're checking. Does everyone have 8 electrons? And did we use 32 from step 1? Well, we've already checked. I used 32. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. Okay? I've done met both. Now, what can you tell me is happening right here with these electrons? What's happening with these? What's happening here with these? And here. So when they're shared, we're going to erase the dots and we're going to put what? A line. Now you can draw. Okay? And we will talk about what the dots and the lines mean tomorrow while I hand out homework.
Are you doing tutoring today?
I am. I'm doing today, Wednesday, and Thursday. All right, your homework practices bond types and ranking. You guys have to study vocabulary. Like the possibility.
What did you say this for?
I said, you guys have to study vocabulary. This is on bond types and ranking and order.
What's the vocabulary?
You're sitting here. Like
I feel like
What part is considered the
I can't go
vocabulary?
in my back here.
molecules, diatomic molecules, single,
What?
double, and triple, bond energy, bond length, that kind of stuff you gotta study.
You forgot something?
you are worse.
Wait, what do I have?
Get some water.
Director, what do you need?
No, I got it. I got it.
No.
Water.
I got it.
Look at some beer food.
No, I'm sorry.